Hello, everybody. Welcome again to another live stream. So, hi all. Today, again, the same thing. We'll be grinding lead code. Yeah, I know I have not been doing coding like from past few days. It's something like I'm switching between platforms from Code Forces to Lead Code and then the Lead Code to Code Forces and all. So I'm not right now. Currently, I'm not sticking to only one platform. So kind of two platforms I have right now. So I'm trying to switch from Code Forces to Lead Code and then Lead Code to Code Forces, and that's how I'm trying. Yeah. So as usual, today also we'll be solving questions. We'll be seeing approach to some good and beautiful questions. What I observed was like in last to last contest. I don't remember the exact name. Maybe let me check. There was a question, weekly question number third. That was really amazing. It was like similar to a Cadence algorithm, but a upgraded version of that. No. uh, Maybe 427. Let me check this one. Yes, this question. This question is really amazing question. It has some kind of, I haven't solved it yet, but I did see the approaches and tried a lot of stuffs. I was trying it during the contest time, but not exactly during the contest. I gave the virtual contest, so I tried solving it, but I was not able to at the during the contest time. But after that, when I saw see the solution, like even then also I was not able to understand it properly. I saw 2 3 videos on YouTube um, to clarify my doubts, but still I was not able to. But somehow I had in my mind that I have to solve this question at any cost. I need to know how the approach is, what is the approach. So there is a YouTuber, you must be knowing, Larry, named Larry. He always puts up some coding uh, questions. He solves daily challenges every day, and also he give contest and uploads the video of the contest. Larry is his name. You can check his video. Like initially, I was not able to understand his logic also, but after that, um, after doing some dry runs and taking 2 days of whole to understand it properly, then I was able to clarify my doubt and whatever things that I had in my mind. So, so now I understood this question. I'll be trying this question. I'll be explaining this question on this stream. I intentionally did not solve it because I wanted to solve it on the stream, and I wanted you guys to also uh, take what I learned. So that is why I did not solve it. So okay, just a second. Yeah. So let me open my. Okay, so let's read the question and see what this question says. So the question is, you're given an array of integer nums and an integer k. Okay, so we have been given an array of integer nums and an integer k. We need to return. Okay, we need to return maximum sum of a subarray of nums such that the size of the subarray is divisible by k. Like it should be divisible by k. Okay. Right. So what the question asking is, we have a subarray. Let's take this as an example, as negative 5, 1, 2, negative 3 and 4. This is my subarray. I want to find a subarray. This is my actual array, and I want to find a subarray whose size is divisible by k. So k here is 2. That means I need to find a subarray whose size is 2 or size is 2 or size is 4 or size is 6 or size is 8. Like they all are divisible by 2. So I need to find a subarray whose maximum sum is like divisible by k. So I needed to somehow figure this out. So the approach that I was thinking was kind of similar to my Cadane's algorithm, because uh, Cadane algorithm is simply, I don't know if I'm writing the spelling wrong or right, but Cadane's algorithm approach is to find the maximum subarray uh, in an given array. So if this is the given array, I need to find the maximum sum. So maybe if I take this as our subarray, this will be my maximum sum. But the only condition changed here is it should be divisible by k. Now how to handle this part? That was something was very interesting. So the brute force approach, if something comes in our mind, is a kind of a brute force approach, which will be like, take two size array, how many whatever two size array we can possibly take, we'll take these, and out of those we'll calculate the best one, whose sum is maximum. I'll be storing that. So probably these two will be the maximum sum. Now I have taken two. Now its multiple is like 4. So I will be taking 4 size array. So these two are the 4 size array that is possible. Out of these, what is best, that will be compared with the best one, and the best will like contain the best answer, possible answer of size 2, 4, 6, 8, anything. Now we'll go with size of 6. We even have no, we don't have any size of 6. So from here onwards, it's not possible. So I can see 2 is possible, 4 is possible, right? Size of length 2 is possible, size of length 4 is possible. So out of those, the best answer will be 4. I think if we take this as a subarray of size 4, this will be our best possible answer, right? So this is how the question will flow, and this is the brute force approach that we will be taking if we want to solve this in O of n square complexity, because every time we are iterating. Now how we can approach this question in lesser time complexity? We need to reduce the time complexity. Earlier the time complexity was O of n square. Now I need to have O of n time complexity, or the maximum that I can go is n log n time complexity, and we need to solve this in these time complexities. Now there is something you should be we observed, like by after seeing the solution, I observed something, that if we are taking k as 2, now let's see what will happen if we take k as 2. So we have this size array, we have this size array, we have this size array, and we have this size array. So these are my possibilities. Now Hmm. Okay, I think I should take K as 3, maybe just in order to explain it in a better way. So let's for now consider this as a size of 3. So if we take these 3 as a subarray, these 3 as a subarray, and then these 3 as a subarray, so we have these answers. Now I can see 3 size subarray. There is this subarray and this subarray is also okay. Okay. Uh, yeah. So what we we will be doing is, if we take even 2, let's consider 2 as our subarray. So if we consider this as one of my subarray, and then this is one of my subarray, then we don't have any subarray, right? Now there's still something left in this subarray of size 2. So if we consider these two as our subarray, and then these two as our subarray, then I would say all are completed. This and this. So what we did is, for size k is equals to 2, we iterated this subarray, start keeping my start point as 0 initially, and then my start point as 1. So then we know that we were able to cover up all the subarrays of size 2, right? We started from 0, we took a size of 2, 2, and then we started from 1, we took a size of 2 and 2. So we were able to cover. Even if you check this out, this these are the 4 subarrays that we possibly can have, and all the 4 arrays, subarrays are consumed over here. Now this after this, I even need to know um, if my subarray k size, if I upgrade it to 4. So for 2 it was fine, for 4 I want to have something. So for 4 also, if I see, if I start from here, 1 2 3 4, we can have till here, and if I start from here, we can have till here. Right. Okay, I think something I understood and something I do not. Funny, huh? Okay, let's dive deep. I need to know, like, if k is a sub size sub array, and that too in the same iteration whichever we are following. Hmm. Okay. Right. Right. Got it. So what will happen is we are calculating 2, 4, 6, 8, everything at the same time. This is how we broke down this problem. So how are we handling this 4 size length of array also, because we need to handle this 4 also. So how we did that was, initially I took my starting point as 0, 0th index is my starting point, and my k as 2. So I took my k as 2 and my this 0 as my starting point, and then we picked these two values and checked whether this is my best answer or not. So I updated this best with uh, I would say -4 initially. Initially it will be int min or something like that, and then we'll be updating it with -4. After this, we jumped to the next subarray. So I will be having some. So the Cadence algorithm keeps two things in track. That is mm, current. I don't know. My hand is not working. Current subarray sum and max subarray sum, right? So this current subarray sum will iterate over each index and will add that in the answer in its current sum, and then it will compare whether the new that sum that is being formed is greater than my max array sum or not. If it is, then we will be updating our max subarray sum, else we'll be continuing the same thing. And if my current subarray sum reaches lesser than 0, we'll initialize it with 0. This is something we generally do in our cadence algorithm. So that is the same thing that we have to do over here also. So this is my current sum and this is my maximum sum, maybe the best, maximum best and the current best, something like that. So in current subarray sum in cadence algorithm, what we used to do, we used to add every index value, right? But here we need to add a range of value because k is something starting from 2, so we need to take two range of values and then apply the cadence algorithm. So what will happen is, if initially the current sum will be -5 plus 1, that is -4. This is my current sum. If it is greater than my max best, I'll update my max best as whatever value we have in our current sum, and then we will jump to the next index, like k plus. So 2 and 3, at this position we reached. Now we will add this sum in our current sum, right? So if there is one thing, like if it reaches lesser than 0, I will be updating it with kind of 0. So maybe current sum is 0, what I am expecting it to be. And then we have 2 minus 3, that will be like updating it with -1. So is this current sum better than the max best that we have? Yes, it is better. So we'll be updating it with -1. Okay, and it's still lesser than 0, so we'll update it with 0. And then we'll jump 2 places after this, and we'll check if there is 2 values or not. So okay, we don't have any 2 values to compare it with to have the sum, so we'll stop here. And then we'll do what? We'll start from index 1, taking 1 as our starting point. Why we are taking it? I think eventually you will get it. If you'll try to think on it, if you'll try to observe it carefully, we'll be only iterating on 0 and 1 and taking these two as our starting point and nothing else. So if I'm taking 1 as a starting point and then iterating, so what will happen is, let's see. Till now my max best is like -1. So we have this as my current sum. So 2 1, that is 3. So is 3 better than -1? Yes. So we'll update our max best with 3. So we started from here. We'll jump 2 places from here, and what we'll do, we'll add these two. These two values will be added inside my current sum. So 4 minus 3, that will give me 1. So 1 again will be added. Why I did not make this current sum as 0 again? Because it was positive. If it would have been lesser than 0, I would have made this current sum as 0 again, but I did not do this means that we are considering this whole array. We are considering this whole array. This will give me the maximum best. So this is of size 4. You see, we are considering this as a size of 4. So we are following the same rules that we had while we were doing k. What the condition says, like k should be divisible by k. So 2 4 6 8, we are doing the same thing only. So this will give me 4. I'll update my max best as 4, and this current sum will stay as 4. And after that I'll jump to the next index, and we are out of bound. So we are good to go. So k was 2. We iterated, we took this as a starting point and this as a starting point, and we did the normal O of n time cadence algorithm with taking 2 as 2 size of subarrays, because k was 2. Now the point is, why I iterated only these two? Because if you see, they will cover everything. Whatever we wanted, it'll be covered by only these two iterations only. So if we want of size 2, you see, size of 6, if we wanted a size of 6, maybe if there is one more size value, let's suppose 2, there is one more value as 2. So what will happen? We'll have a 2 size of array again, a new 2 size of array. And if we see, we can have a 6 size of array as well, starting with this as our starting position. So if we are considering 6 size array, then this should be my starting position. I'm already starting at this position. Even we want a 4 size of array, we have to start from this position, then 4 size, then this position, and then 4 size, and this position, then 4 size. So that this will is going to be handled by my 2 size of subarray easily. Okay, if okay, Let's see if this can be handled right. uh, if we had a four size of subarray, what would four size, one, two, and these are the three sizes. So if this is my starting position, is there someone starting from here? Yes. This subarray is starting from here, so we can consider this as a sub size of array. So if someone starting from here, yes, for two size of subarray, if we consider this as my starting position, this will also be covered, and this will also be covered, and if we start from here, this will also be covered. So if we only iterate at these two positions, rest everything will be covered automatically. We don't have to worry about rest of the things. So that is how we are working. It's like, try it by yourself once, understand it properly why we are only iterating as k equals to 2. Take 3-4 examples with yourself and dry run it, because it's something that you won't get it at once. You need to understand, you need to have a in-depth knowledge of this, then only you will be able to understand it properly. So try it with 2 or 3 examples, see how and why we are doing this, and then solve it. So I'll try to code this out. I haven't coded it also, so let's see, let's try. So one more thing, that always we are taking this as like, if I'm at this position, I want the sum of this. So maybe pre-sum, there's something like pre-sum that will help me in finding my answer. So we have a vector of integer, or maybe I'll take it as long. Pre-sum, this will be of nums of size. So pre-sum, I am taking 1 based index and not 0 based index, so that's why I will be updating my I plus 1 pre-sum with pre-sum of I plus nums of I. So this will create my pre-sum 1 based index, and after this what I have to do is I will be iterating over k, and now this will not go to n square complexity. Why it will not go to n square complexity is something really good to understand over here. So I was saying that if k is 2, I'll be iterating twice this array. What if k is like 10 to the power 5? We had an array of 10 to the power 5, and we have an array of 10 to the power 5, and k is also 10 to the power 5. That means I'll start from 0 till 10 to the power 5. I have to iterate starting from 0th index till 10 to the power 5, and every time I have to iterate for every k. I need to iterate this whole array. That is what you must be thinking over here. But what will happen is, if you take a size of 10, suppose 10 to the power 5, and your array is also of size 10 to the power 5, you'll start from here. The maximum length of sum of array you can take is 10 to the power 5, and so you will take the whole array as your pre-sum and then calculate your answer. The moment you will reach over there, you won't be getting the 10 to the power 5 subarray of length. It will reduce to 10 to the power 5 minus 1. And if you reach over there, so then also you won't be having a length of 10 to the power 5 from starting from this position, because 2 elements has also already been eliminated. So that means you are not calculating anything, you are just iterating over this array for rest of the time. So it will be like, still it will be O of n time complexity. And if you are thinking what will be the worst time complexity, is something, if you go by half, maybe if size was of 3, you could have gone till three size of subarrays starting from this. So the maximum that the time complexity can be is half of this 10 to the power 5. Is like 10 to the power 5. So this will be like the maximum time complexity, I would say. Or even 2, we can take 2, but 2 is constant, it's fine. So n is the only time complexity that will happen. If you are taking 1, you will be iterating only once. If you are taking 2, 2 times, 3 times, but till half only you will reach. After that you won't be able to get that much of length. So k will always like will always be in range of my O of n time complexity. It will not go beyond that. So that's why the time complexity for this is also O of n and not O of n square. So what will happen, we'll be iterating, and for each k, each time we'll be iterating, we will iterate the whole array. So my current starting position will be I, and maybe I'll take my current max as an integer min. Now for int, okay, let's see this. While current start plus k is lesser than nums dot size, that means I'm checking that if that subarray is available or not. If that subarray is available, that means we will be taking the pre-sum of that subarray from that position. So pre what if I initialize my current max with 0 right now, instead of initializing it with int mean, I will be having something as global max that will be like integer min, because we need to take something. We'll do what, we'll add it in my current max plus is equals to pre-sum of current start plus k minus pre-sum of current start. Probably this will be like, let me check once that my pre-sum is being calculated correctly for every okay. And then current start plus is equals to k times it will be added. I'm printing return -1 for now. Let me remove this and let me check if my pre-sum is where. Oh, Seriously, I'm like, there should be one more bracket. Let me take this as an example. So initially this will be like -4, and this will be -1, and then this from starting from this is 3. Like, okay, I think it's fine. For size 4, this is -10. And there should be one more. The case is 4, right? I'll say if it is even equals to. This is -4. This is -1. That's fine. And this is 3. And this is 1. Right. Now it's okay. So this will be my pre-sum. Okay, fine. So current max plus is equals to my pre-sum. Now my global max will be maximum of current max comma global max. Now if max is lesser than 0, make this current max is equals to 0. Maybe I'll make this as, let me do it. I'll make this as delta, and it's delta and current max plus is equals to delta, and global max is equals to maximum of global max and current max. Perfect. And at last we'll be returning global max. Let's see. Okay, test case 1 passed, test case 2, test case 3 failed. It should be -10. So what I can, no, okay. What if I comment this, but I need this, right? If current max becomes lesser than 0, I don't uh, why to add that, make it 0, or even like make it equal to delta. Why my output is 0 is okay. mm, it's hard to remember the cadence algorithm. Okay. Now it's negative 14. Oh, now this case satisfied. These two failed. What? Okay, I am updating it with the delta, and then so maybe I'll make it 0. So if current max is lesser than 0, I'll make it 0, and then add the delta to it, right? And then we'll do it. Okay, let me try some other test case. 3 and negative 9. What if k is 1, and for same case I want k is 2. Let's see. Okay, let's submit it and see if it is working. uh, uh, okay. Oh, okay. L long min. Nice, accepted. So this is something. तीन तीन चावल तो फिर 2 कर दो. So this is something. Okay, so Yeah, so this was the solution for this. If so this is like very similar to Cadence algorithm, but a little trick hidden with it. So it was really nice to solve it, to understand it. So first thing first was like understanding is this was a really a task which you would have like tried it. I'd say this will go to my description box because this is really a really good question. So you can check this question. Try this question by yourself, and really, if you want to like get some intuition or idea, you can go back to this stream and have the idea on this, because what I saw some of the videos or many of the videos where they were using some kind of modulo operation over k on k, and they were finding some maximum answer, which was like way beyond my mind, that what is happening and why we are doing some kind of modular operation and what is happening with all those things. Thus I did not understood that approach properly. But yeah, where I tried it by myself, I saw Larry's video. He solved it using a proper cadence algorithm, and the when I tried it, when I dry run it, this question, it was like super clear to me, like why we are doing. So now I understood that why we were doing that modular operation also. So even modular operation is will not be that difficult for me to implement or understand now, if you know this solution. So try this by your own. If you understood the modular operation solution, that is perfectly fine. I don't have any problem with that. That will be like really great if you know the modular operation, how they are working. But I was something I did not understand, so I needed to have some more clarity over it. So I jumped to this. Yeah. So this was a really good question. After this, I was thinking of solving some bi-weekly and weekly, these two contests I wanted to give. So let's give these two contests. And also there was one question on code forces, which says like uh, k periodic Garfield or something. K P R I O D I C K periodic Garland. Yes. So this is something which I wanted to also try. Mm, so let's see. It has a rating of 1900. So nice. Let's try. Let's give these two contests. After that, we'll solve it. So before that, I'll take a 10 minutes of break, and then when I'll be back, we'll we'll do the. So don't go anywhere. Stick with me. After 10 minutes, we'll be doing contest questions and we'll be seeing the approaches to those questions. And yeah, then we are good to go. So what I'm thinking is like I'll give back to back contest, both the contest, and then I'll upsolve those questions. So that is how I'm thinking. So I'll be back in 10 minutes. Don't go anywhere. And yeah. back. Okay, let's go. Okay, so bi-weekly and weekly. Which one should I go first? Is it bi-weekly or should I go for weekly? Bi-weekly or weekly? Weekly. Maybe we'll start from back. So weekly, then bi-weekly, because this has already been done. So let's go weekly. Let's start with weekly, and then we'll go to bi-weekly. Let me close the door. Okay. Yeah, it's really cold over here. I'm, I'm feeling really cold. I don't know. Feels like I'll catch a cold sooner. Okay, let's go. So you are given a positive number n, return the smallest number x greater than or equal to n such that the binary representation of x contains only set bits. Okay. I need to know, like, after this, what is the number greater than or equal to? Return the smallest number x greater than or equal to n. So if n is already all the bits of n is set, that is simple. So if not, then set those bit, and whatever number will be generated will be our number. Okay, this kind of let's create our answer while n is there. Bit, the last bit, I say, take the last bit as n and with 1, that'll give me the last bit. Now if it's like 2 to the power 0, 2 to the power 1, 2 to the power 2. So I need to know, like, what times we are running. So times is equals to 0, so answer is equals to answer plus power of 2 comma times will increase, and n is equals to n right shifted ones. And finally I'll return my 715.3. Let's submit it. Okay. Identify the largest outlier in the array. Okay. You are given an integer array nums. Okay, we are given an integer array nums. This array contains n elements, where exactly n minus 2 elements are special numbers. Okay, Exactly, n minus 2 elements are special numbers. One of the remaining two elements is the sum of these special numbers. One of the remaining two element is the sum of these special numbers, and the other is an outlier. An outlier is defined as a number that is neither one of the original special number nor the element representing the sum of those numbers. Note that the special number, the sum element, and the outlier must have distinct indices but may share the same value. Return the largest potential outlier in the nums. So I need to return the largest potential outlier in nums. So we have this as so there will be like I can see 2 3 uh, adding 2 3 will give me a sum of 5. So these three are the number and this is the outlier, because we need to find the largest potential outlier. Now, is it so? Like, what the first thing is coming in my mind? Sort the array, return the last value. But is it so? It's not. Mm, it's not always the case. One case that I can see is like if I sum up the n minus 2, sum up n minus 2 elements after sorting, which sums up to the last element. So second last is now the outlier. Okay, so now the two things that is coming in my mind, either the last element or the second last element will be the outlier. Now, is it always the case? That is the thing that I want to know. Is it always the case? If not, then what is the case, and how are we going to handle that case? So for this it's simple. For this, if we sort it -6, -3, -2, -1, and 4, if I sum up these elements, because there are negative elements also, so they will sum up to some other negative element. But if I sum these, then we can make this -3, -2, -1. We can create -6. Right, and for this, now this is an outlier. 1 2 3 4 5, summing up these will like make up 5, and now the next 5 is the outlier. Oh my god, my hand is even not working properly. It's kind of freaked. Okay, so I somehow need to find the outlier. Like the negative numbers may create some problem. Like, what if all the numbers are positive, and the mix of negative and positive numbers is somewhat will create problem. जब आते हैं ब्रेक पे निकल जाते हो तुम यार. तो आप आते ही ऐसे टाइम पे हो जब मैं ब्रेक ले रहा होता हूँ. आप डिसिप्लिन्ड नहीं हो, इससे ये पता चलता है. Okay, like what we can do is let's separate the negative and the positive numbers. Will that be of any help? The examples are not very accurate over here. What can we do? Like if we separate the negative and the positive numbers, like no kind of data structure question is this is like no data structure question. Okay. So if the arrays are negative, probably I need to sum up all. I need to leave only two elements, right? So if we do kind of a sliding window of n minus 2 size of subarray and check whether we have element in our map or not. Okay, so kind of we'll be keeping a map. Let's assume we have a map. We kept -6. We kept -3, -2, -1, and 4. So all of them has a frequency of 1 right now. So till n minus 2, like 1, 2, 3, 4, 5. So till 3 elements will be iterating over this, and we take a sliding window and we check whether now this sum is present in my array or not. If that is present, I need to know the last element. That will be given by total sum minus this whole sum. So that is what will be given, and that is what we need to maximize. And then we take this as our, if it is present, fine, else we'll like remove the last element, add the new element to it. So this is my new subarray of size 3. Now I will be checking whether I have this element or not. Yes, we have. So we'll be like reducing the frequency of rest of the elements, obviously. And do we have -6? Yes, we have -6. So total sum subtracted this will give me 4. So do we have 4? Yes, we have 4. The frequency of 4 is there. So okay, so this is some kind of approach that I am thinking for this. So what I'll be doing is sorting num start. Okay, let's take left pointer as 0, right pointer as 0. Now my right is lesser than, till then we will be iterating over this array. Now if I need to have a map also, and all the values should be there, and a presum also. So kind of okay. We have integer frequency. We have this frequency map, and maybe I'll take long as tsum, which is like total sum. And also frequency map of nums I plus plus, and I need a result. Result will be kind of integer main. Let me take it as integer main, because possibly there might be a number which is negative, so I don't want that. Okay, so we are doing a sliding window on this, and taking sum from start and till n minus 2. So maybe we can take like k is equals to nums dot size, which is nothing but 1 2 3 4 5 5 5 minus 2, or even let it be. What I'll do is current sum. I need some kind of lots of variables, huh? Okay, current sum plus is equals to nums of r. Now if r minus l plus 1 is greater than my if the sum length is greater than k minus 2, that means greater than 3, so I need to remove it from the last. I need to remove something from the last. And also, while I am doing this, I need to reduce it from my frequency map of nums of r minus minus. I'll reduce the frequency of frequency map. Okay, 4 people are watching, but the like is only 3. Okay, so I need to remove it from my current sum. So current sum minus is equals to nums of L and frequency map of nums of L plus plus, and L will be increased. So this will make sure that my window remains in a specific location, only of size k minus 2. Now if r minus l plus 1 is equals to k minus 2, then we need to do something. Then we need to find the outlier, and which will be returned. So if it is k minus 2, what we will do, we'll check if this current sum is present in my map or not, and the frequency of that current sum should be greater than 0. So if frequency map dot find this current sum is not equals to frequency map dot end, that means it is there, the value is there in my frequency map. We'll do what will also I need to check and frequency map of current sum is greater than 0. I don't know why I could have directly applied this, but maybe it will add that value in my map. I'm not exactly I don't exactly know, but possible. Okay, so frequency map current sum is not equals to frequency map dot end, and frequency map of current sum is greater than 0. That means this value is there in my map. So if it is there, I need to find the outlier. So outlier will be someone among them. So if t sum, okay, then also I need to check if this condition is true. I need to check in my frequency map dot find. I'll do what? Frequency map of current sum. I'll reduce it for once, and in my map I'll find again t sum minus current like this sum is equals to, so current to this current sum is once more, so twice it will be like two times of current sum. That will give me the element. If it is not equals to frequency map dot end, that means it is there, and same thing, frequency map of t sum is greater than 0. If it is 0, my result would be maximum of result comma. I should have stored it somewhere because I'm using it often, very often. And my R will increase, and at last I'll return my result. Okay, 1 LL multiply really I no, you want me to explicitly oh sorry, I need to typecast this 1 LL it's 10 4 and 5. 10 4 and 5. Let's submit it and see. It never reached. Okay. For this example, what happened is minus 402 minus 288 and 907. Minus 40, okay, now these and these were there, and we were not able to find any outlier. Two 88 is the outlier here because we sorted, and it means sorting and doing the mm, sliding window approach is not working. What else can we think of? 288, even starting with the lowest element is not starting with the highest element. Like we can start from any of the element. 288 is the outlier, so this plus this will be equal to like something this. So I need to add these two elements. 907 plus 402 minus, that is 505. So I need see, there is like possible of doing a recursive approach of like picking and not picking of elements. But that will be, what is the like length? So it's 10 to the power 5. So I cannot go and like a brute force approach or recursive approach. Can we do some kind of a binary search approach? Like we need few things for binary search. The first thing is like a sorted array, and on the answer we can apply binary search. Like I want to find a sum of, is it possible to find a sum of this sum of this size? How can how can we approach? I was thinking of sliding window, but it will eventually will not be applicable. I cannot go and square complexity using binary search. I don't see uh, of applying binary search over here. I need to what if we think of a kind of a linear time, some kind of approach, minus 402, kind of two pointer. Is it possible? No. Like, are these two conditions, like this is a sliding window approach, and we can also try for a two pointer approach of selecting. Yeah, okay. Can we try something circular? Can we try something circular? Let's see. 907, then start with 402 again, then minus 288, and then 505, and then 907. What we are doing is, like, we are taking these two, then these two, then these two, and then these two, and then these two, and then these two, and then these two. So this was something which was left. So if I do a kind of a circular, if we generate a circular type of array in sorted order, then I think we'll be able to identify if it is possible or not. So I need to just make this array circular. I add it in my map. Till this I don't have to do now. Okay, also is fine. Now I will be doing what? Nums dot pushback. I need to go till k only. So nums dot push back nums of I. So starting 0th value will be pushed at last again, and k is something like this, current sum, and we are iterating our nums dot size again. That will be like a total of okay, 10 for 5, 10 for 5, and for this we wanted a minus 288. That is what we have over here, minus 288. My answer will always be in integer, so we have an integer as my result. Let's see. Okay, so circular is also not going to help me. Let's see, 342, 175 minus 167, 754. 754 is the outlier. So if I sort it, minus 167, 175, 342, and 754, and that is also same. So 2 754 is the outlier. Means sum of these two elements is giving me this element. Sum of 342 plus 167 is giving me 175. So outlier is 754. Okay. For this number to become an outlier, I need to have something. Uh, See, if the array is sorted, there is something I can figure out. If the array is sorted, if okay, let's think in a different way. So what we can think of is, if I want this to be an outlier, I want something from here. Interesting. Why can't we think of in sum? Okay, let's let's reduce some few things from here. I want this to be my sum. I want to make my outlier maximum, right? So we have like 402, 288, 505 and 907. Okay, now I want this sum. Is it possible, like, I know this total sum, I want this to be in, like, let's suppose this is the outlier. Okay, I okay, total sum, I know total sum. This is my t sum. Okay, I can see something I can see. If I know total sum, something like question mark, maybe x. If I remove this element from it, I want this to be the sum. So x minus 402 minus minus 402, that is plus 402. It's kind of minus. Let me keep it something like this. X minus of minus 402. I will be getting the total sum of this. Now from this I'll try to remove one element from everywhere to make sum this. Is it right? Okay. And from this I want to make sum as this. So how much do I need to remove? So the remaining is this. This is my remaining equals to y. Y is remains. From remaining, I need to see remaining minus minus our outlier, or maybe let's not say it outlier. Remaining minus z should become equal to this element e. So z is my outlier, and this can be done using map. Every time I want my sum to be this, for this I know the rest of the sum. Okay, and now the things are becoming much more clearer. So even we want a frequency map. Do we want it? Yes, we want. We don't want to sort the array. It's fine, don't sort the array. Put it in my frequency map. I need the total sum. I need the size. Now from here, let me remove everything. Let me do it once more. Okay. Int I equals 0, I is lesser than dot size, even I have k. Now I'm saying that I want to make sum of this as my sum. So int my element, I will say current element as my nums of I. Now t sum, temp sum is equals to t sum, uh, or I would say sum left sum is equals to total sum minus current element. So this is what a total sum left. Now I want to know how much should I remove to make it equal to current element, make this left sum equal to current element. To remove will be equals to something total sum minus this will give me my outlier. Outlier will be t sum not left sum, the sum that is left minus the current element will give me what needs to be removed from this total sum to make it equal to this. Now if this outlier is present, now two things. Two things. Okay, yeah. The only thing I need to check is whether this outlier is in my map or not. If it is in my map, I'm taking this as my sum. And what if 402 was the only element that became my outlier? If that became my outlier, say I wanted this sum and this is the only outlier and the only element that I have is its frequency is ones, and I'm taking this as this sum and this as the outlier. It's not possible. For that handling, not sure, there is some kind of a doubt over there. Here, if the element is already there, its frequency is only once. If like the number repeats itself, frequency map current element. I reduce the frequency of the current element. Now if frequency map dot find outlier, and what if the outlier is among them only? So that element has to be removed. Oh, that's fine then. I hope this should work. We found an outlier, and then also frequency map of this outlier, the frequency of this is greater than 0, then we can say that result is equals to maximum of result comma outlier, and frequency map of current element will increase. And at last I'll return result. -1045 -22 -288 also 754. Right, this works. Let's submit and see. Fine. I went over like lots of confusion, but maximize the number of target nodes after connecting trees 1. There exist 2 undirected trees. Okay, no, it's fine. There exist 2 undirected trees with n and m nodes. Okay, with distinct labels in range 0 to n-1 and 0 to m-1. With total of n and m nodes, and the range will be like from 0 to n-1 and 0 to m-1 nodes respectively. You are given a 2D integer array edges 1 and edges 2 of length n-1 and m-1 respectively, where edges of I is equals to ai bi indicate that there is a edge between node ai and bi in the first tree, and h2i indicates edge between ui and vi in the second tree. You are also given an integer k. We are also given an integer k. Node u is target to node v. Node u is target to node v if the number of edges of on the path from u to v is lesser than or equals to k. Note that a node is always target to itself. Return an array of an integer answer, where answer I is the maximum possible number of nodes target to node I of the first tree. If you have to connect okay, I messed it up. I need to understand from here. Okay, node u is target to node v if the number of edges on the path from u to v is lesser than or equals to k. Note that node is always target to itself. Return an array of an integer answer, where answer I is the maximum possible number of nodes target to node I of the first tree. if you have to connect one node from the first tree to another node in the second tree. Note that queries are independent from each other. That is, for every query you will remove the added edge before proceeding to the next query. That is, for every query you will remove the added edges before proceeding. Okay, every query is independent of each other. It's not there is no dependency. And what about this? This is also the only difference is I suppose from in the constraint nm. Yeah, it is 10 to the power 3 and this is 10 to the power 5. So if we know the solution of 10 to the power 5, the both of the solution will be accepted. Let's think. You got 30 minutes to think on this question. Okay, so this is the edges of I, 0 to 1, 0 to 2, 2 to 3 and 2 to 4. Okay, so this is one edge and this is another tree. K is 2. For I is equals to 0, connect node 0 from first tree to node 0 from the second tree. If I connect these two nodes, what will happen? Node U is target to node V. If number of edges on the path from U to V is lesser than equals to K. Note that a node is always a target to itself. Like a path from U to V is lesser than equals to K. Return an array of n integer answer, where answer I is the maximum possible number of answer I is the maximum possible number of node target to node I of the first tree if you have to connect one node from the first tree to another node in the second tree. I'm not getting exactly the question. What do you want to say? Till here it's fine, there is nothing to understand. The only thing to understand is from here till here. Node U is target to node V. If the number of edges on the path from U to V is lesser than or equals to K. If number of path from U 0 to 0 is lesser than or equals to k. Connect node 0 from the first tree to node 0 from the second tree. If I connect this node, what will happen? For 1 it is 9. What is 9? Return an array of n integers. 1 2 3 4 5 and 1 2 3 4, where answer I is the maximum possible number of nodes target to node I of the first tree. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8, and connect एक दो तीन चार पाँच छः. It's like number of edges from path U to V. Node U is target to node V. I cannot understand. I'm not able to understand the question properly. If you can understand, chat, can you explain me these two lines? I need to know, and how it is the answer is being generated. And node 4 from the second 3. Connect node 3 and 4. You're saying something like that, and like every query is independent of each other. For second, connect node 1 of first tree to node 0 of the second tree. If I do this connection, it is saying only 7. Why it is 7? Like 1, from 1 to 0. No, node U is target to node V. If the number of edges on the path from U to V. Oh, come on. What is the thing I am missing? Note that node is always target to itself. That is fine. Node U is target to node V. If the number of edges on the path from u to v is less than equals to k. So if I see 0 to 0, from 0 to 2, 0 to 3, 0 to 1. So 1, 1, 2, 3, 4, 5, 6, 7, 8. How come it is 9? From 0 to 0 there is like 1 edge. So from here 2k distance पे maximum कितने nodes? How many nodes are there at a distance of 2? There is 1 edge, 1, second edge 2, 3 and 4, a total of 4. From here we can generate, right? If this is my starting point, 1, 2, 3 and 4. Now 5, 6, 7, 8 and no 9. Okay, let's see. Node 1, if I connect it to 0, what will happen? 1, 2. That is the maximum. 2, 3, 4, 5, 6. And if I connect 2 with 4, if I connect 2 with 4, let me check. So 1, 2, 3, 4. This side will always be like 4. Will it? Not sure. For this tree it's 4, but for other it may not. 4, 5, 6, 7, 8. For this was 7, this was 6, this was 8. Oh, there is one node that I am missing. Okay, there are 8 edges, so 9 nodes. Total of 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. So total of 9. For 3, the first tree to node 4, 3 also, from 3 also connect to node 4. So this is also going to be like 1. Okay, there is an edge of 3. You see here. So there is no root, as if. So there's something we need to pre-calculate. So from here, if I go till here, like 1 2 3 4 5 6 7 8. So 8 for this, and from 4 also if we connect to 4, so 1 2 3 4 5 6 7 8. Yes, got got the point. So here for this question, I'll be able to solve it using n square complexity to find from every node to every other node. What is mn? That is maximum. It can go till 1000. So n square complexity is accepted for this. So for every node in the first tree, I'll iterate and how many edges maximum I can go, or how many unique nodes I can visit from here. Maximum of k distance will be my answer, right? Will be for this. And if I want to connect, I can connect to any of the nodes here. What if I like connected 0 with 4 only? Why connected with 0? So 1 2 3 4 5 6 7 8 9 nodes. For the second tree, I'll always try to pick that place which has the maximum, which will give me maximum number of nodes, isn't it? I'll connect to that only. For left tree, it depends, because left tree I have to iterate everything, right? Correct. For right, I don't have to do anything. I will have to, like, if k is 1, I can connect to any of the node here. Try to connect with the maximum. So for second tree, I don't have to like use my brain. I'll just connect it with this, the one which will give me maximum. I need to somehow like pre-calculate and store. So this and this, and I found I'll return 1. I kind of return, I'll return 0, or even like I'll return 1, because I'm considering that node also 2, but for this also 1 will be in my map. For this also 1 will be in my map. The maximum will be 1 in my map. And for this 1, so there will be an edge. K equals k is also, it's kind of edge we are talking about. Path means edge. I need to create one path. How many we have here? 1. We have 1 plus 1 path we are creating 2. Okay. The main thing was like, it's it will be two undirected connected trees. There should not be. Okay, it should be valid tree, right? So pre pre-calculate. So there is an edge from here to here. I'll be creating adjacency list. I don't know the edges. It will be in range only. So maybe I'll create an ordered map. Map for this for int and do I even have to remove anything or something like that? No. So it's fine. Adjacency list 2. This will be my adjacency list 2, and also I need adjacency list 1. Maybe yes. So DJ adjacency list 2 of edge of 0 dot push back adjacency list, sorry, edge of 1, and because it's an undirected graph, I need to reverse this. Now same thing I'll be creating for adjacency list 1. So we have that adjacency list created with me. I need to find the maximum that we can have. So for second, there is something I'll always try to calculate, connect to that node that will give me the maximum number of nodes, so I can connect to anyone, right? Why to connect to 0 or something like that? So pre-calculate for adjacency list 2, maybe the starting node. We can consider anything like adjacency list 2. Okay, and I need a starting node. that is 0. So this will return me something kind of max node. After doing pre-calculation, this will return me the max node number of node that I want to connect. K is one something called edges. That means we are talking about edges. So let's send k plus 1. So max node like will come to from here, whatever node from here maximum we have will be attached to that maximum node. So no, is it so? But I connected with 0. So 1 2 1 2 1 2. So if I like connect 0 with 0, this will be like one edge. So 1 1 2 3 4 5, and this is only 1. 6 for this. 1 2, this will return me like 1. This will have like 1. So 1, this will have 1. This will return me 1. Means it should not store more than k. That is what I'm supposing right now. So it should be like k only. Means because there will be always going to be an edge. So it's always an edge. And if last we are returning 0, we'll have to return 0. Then only it will work. Else it will not work. 0 plus 1. So this will return. No. Okay. So that pre-calculate. I'm thinking of solving 1 and 2 both at the same time. That's why I'm trying a better optimized code. I need something called as visited. I don't want to visit that node again, and it's a tree, right? So if I visited something once, I may not visit. I should not visit it. Not may not. I should not visit it. So I need something. because I don't know though. So visited. Now if visited dot find current node is not equals to visitor dot and that means it is there, simply return 1. Will I be returning 1? No, return 0. There's nothing as rooted node. I like 0 can be anywhere, so if 0 is even here, what will happen? It will iterate till here. It will show me that if we connect to this node, but I need to store it everywhere. What is the maximum if we connect to that node? But I don't need it. I need overall maximum, the global maximum. Kind of global maximum. Right, global maximum will do the job. Now I'll do what is lesser than adj list list of current node dot this will be my new node adj. Key will be as it is, visited will go, and if not visited, then I'll mark my visited of current node. Visited dot insert current node. Okay, so Okay, we visited it. From pre-calculating, I'll be returning and count. We'll get something count, and I'll be returning count plus 1. And I need to know, like, if 0 is, this will return z, 0 here, this will return 1, which should be added over there. This will return, everyone will return 1, and at last total sum plus 1 I'll be returning. So count is equals to 0, count plus is equals to whatever we are getting, and at last will return. So before returning, I will store in my global maximum of global max comma minimum of k comma right. It will return this. Do we need like count plus 1? If like k was 1, even I don't have, I would have not iterated it, but it's fine. If we, even if we iterate, 10 to the power 5 is the maximum that we can go, so it's totally fine. Global max for first it is 2. No, what did I do? I maximum of global max count plus 1 and return, and k will, every time k will reduce, turn 0, or even k becomes 0. So 4 is the maximum. If I connect 1 2 3 4, even 1 2 3 4, from anywhere, that is 4 is is maximum number of nodes that we will get from here if k is 2. And because we were returning like 0 from here, I went to here. This returned 0. Yes, I want this only, and this will return +1 because there will be an edge. So for this it's 4 and for the second it's 1. Okay, fine. So global max is correct. Now what I need to do is I need to iterate over each one. For this also I need somehow to pre-calculate. If I reach node this, what is the maximum that I'll be storing, and for that I have to keep a map. I don't know if I needed for that also or not, but it's fine. I can like use the same method. I don't want any other method. Do I? Because this is my starting. So okay. Pre-calculate one current node adjacency list visited. Everything will be same. Instead of returning 0, I'll be returning 1 from here, and I will have one more thing. Over here, that is pre-calculate one visited so instead of keeping another set, we can keep another map int comma int this will be like visited one, which will even keep. Instead of this, it will keep it will be a map of corresponding to current node maximum of not even maximum, because it will be count +1. I don't need this global max. Adjacency list, and instead of this I'll be having, oh come on, so we have this pre-calculate one. It is equals to visited one dot begin. Well, it is not equals to visitor dot one dot end let's see for the first case once. What? Okay. Visited of, sorry, not here. I need to do it here. Is equals to 0. For 3 it is 2. For 3 2 2 3 1 3 0. For 0 it's 9. How? Okay, it's like mm, sorry, I passed. For 0 it is 7, for 1 it is 2, for 2 it is 4, and for rest for 0 height is 7, for 2 it is 4, 1 2 3 4. There's something. Ah, I got the point where I'm doing mistake. It's same for tree 2 also, and same for tree 1 also. hmm Okay. What mistake? What are you doing? For 0 it is like my starting node, adjacency list 1 k and visited 1. This is initially empty. Hmm, I did a big mistake, but that is fine. That will be like that can be handled. That can be handled. Uh, so, okay. Now there is something that I am stuck to. Is like edge distance we were calculating. So we needed to based on edge we had to do all the stuffs and we did what we did based on nodes, and that'll create a problem. I needed to this pre-calculation is wrong. I need to understand how to calculate, how to do the I need to iterate the whole graph. Anyhow, I need to iterate the whole graph. This can be like two things. I may for the second one I need to only find the maximum or the best. So we can either find the center of this graph. If we are able to find the center node of this uh, graph, it should have been like easier, don't you think so? Why I'm messing things up? Like solving in n square method will not be that difficult because this pre-calculation will do for n square. But if I want to solve it for I need to store it. Okay, let's think. How can we like this node needs to know at k distance how many nodes are there. This node needs to know at k distance how many nodes are there. Same thing for everyone. Like this is for this graph. This node needs to know how at k is equals to 2 distance the total of how many nodes. This node needs to know at the distance of k is equals to 2 how many nodes are there. Everyone needs to know at a distance of 2 how many nodes are there. It's like how many nodes at a distance of k for every node. Hmm. This is the only thing that I need to figure out. If I'm able to figure out this, I'm going to solve this. I'll be able to solve this. And may not that difficult. And that too in O of n time complexity. Like doing it. In O of n time complexity is something I need to handle. Like this is an undirected graph, so obviously there will be no start point can be anything. So even if I take 0 as my starting point, so interesting. How can we do it in O of n? Any idea how can we do it in O of n time? For every node I need to know for k distance how many nodes are there, because that will make my life a lot easier in finding the solution. So this is the only thing that I need to do. After that, the solution is done mostly. How many nodes at a distance of k for every node? Do you have any idea, chat? How can we find how many nodes are there for every node at a distance of k in O of n time complexity? Hmm. Okay. It's kind of some kind of a dynamic programming where we will be storing value to it. Why? This is not even a binary tree. Everyone needs to know at k distance on a nodes are there, or even during running time can be calculated. Let's see the discussion forum. I like no, for not for this. Maybe I'll check for the hard one, because medium one and square complexity is fine. That can be solved. That tree DFS, dynamic programming. The intuition is not very hard to come up with, as for every node in tree 1, the answer will just be sum of these two. The number of nodes that have even distance from it. Target nodes after connecting. Tree zone was a great distraction during the contest, as this problem is quite different and simpler. In a tree, we can partition nodes into even and odd. Hey, why are we doing like? Oh, second question is a little different. You're also given k, and here we don't have k. Then that means this is like n square solution. DFS from each node for up to k edges. Oh, okay. I thought they both are same. Then I can try this one. If they are not same, I'll try this. Okay, I'll do this. Then and in n square complexity only I'll do it. It's fine then. Okay, I'll take a 10 minutes of break, and when I'll be back, I will do it. Short break. See you in 10 minutes. Don't go anywhere. Hi, I'm back. Okay, let's solve this. Let's solve this question now without anything else. Let's solve it directly. आजा नहीं अभी तो कर दे रहा एक मिनट Okay, so let me remove it. I don't need this. Ah, sorry. I need one. I don't need the second one. I only need one. So this will do. And I think I need this or this. Which one? Maybe the second one. I'll take the second one. Okay. So for adjacency list, let's calculate for the first. We have this visited one. We have a for loop that will start from 0. We'll go till adj list 1 dot size or even kind of let's do that. It will be visit not visited adj list 1 let's see if this works or not. For now these are not there. Let me comment it out. Okay. Pre-calculated pre-calculate and I need visited, which will be passed over here, and I need unordered set here of integer visited. If k is equal to okay, I'll look at the base case visited. So this will be visited dot insert current node. So I inserted the current node. Inside my visited I have my count, and it will return count. And it dot first will be my key, Mm, and in my pre calc it dot first will have node count. Okay. Fine, then this will do. Okay, now I need to know. Let me see. Invalid range expression. Okay. Oh, it was an iterator, right? So maybe beacon will work. Let's see. No. Okay, fine then. This IT has been declared. Okay. Let me see. For 0, how many nodes are there at a distance of 5? 2. All 5. For 1, it's 3. For 0, it's 5. For 1, it is 3. For 2, it is 5. For 3, it is 4. And for 4, it is 4. Let's see if this is the case. For 0, 5. For 1, 3. 1, 2, 3. 1, 2. This is all. Okay, so 3 only. For 1, it is 3 only. For 2, it is 5. For 3, it is 4. For 4 also, it is 4. Correct. So this is fine. This pre-calculation is perfect. What I'm right now thinking. Yes, so let me use the example test case 1 also. One, two, three, four, 5. For this, it is 2, 2, 2, 2. For rest, it is 2, 2, 2, 2. And for 0, it is 5. Perfect. It is working fine. So this is what we wanted. This is for 1, and I need global max, something called as global max for it1 is equals to adj list 2 dot begin Now we are working with ADJ list 2. And I don't need to pre-calculate. I need to have something as global max. Secondary max. Secondary max is equals to maximum of secondary max, comma, whatever we are pre-calculating, with k minus 1, I suppose, because this it is 4. Like 1, 2, 3 and 4. If this also 4, so global max is, secondary max is 4 and first is this. So answer, I remove this. Result dot push back IT of second plus secondary max. Okay. 63333. Is there anything else that I added? Submitted. Oh, okay. For k equals 0, if this was the case and k would have been 1, then 33 was correct. If k would have been like 2, 43533. Is it okay? And why is it so? We have a graph as 2 0 3 1 3 2 3 4 and 0 3 0 4 0 2 2 5 0 7 1 6. This is 5. This is nothing. 1 6 and 1 7 7 1 1 and 6. Hey, hi Abhinav, Abhi. कैसे हो? How are you? And my k is given is 1, so the maximum that I can have from the secondary is 1. From the secondary, the maximum that I can take is 1. From the first tree, the maximum that I can take, if k is 1, is like 1 2 3 4. So for 0, I see these are 2 and plus 1. That will be 3. Like 3 is correct, right? It should be 3. My logic is not wrong. The implementation is wrong. Is it so? Okay. For 0 it's 3. For 1 again, if I see on 2 and from right it's 1 3. Total is 3. And for 2, let me see, 3 plus 1, that is 4. Correct. For 3 it's 1 2 3 4 plus 1 5. Correct. For 3, for last 4 it is 2 plus 1, that is 3. It should be something like this. White. Oh. Okay. Okay. I now I know. It's not in sequence. It's not in sequence. That is the reason this happened. I need to order it based on the node. So this pre-calculate, maybe I can keep it as a map. Why not? Yeah. 33453 1144 33453. It's okay. Why it went? Hey, why time limit exceeded? It's given that it will be like 10 to the power 3. I do have this visited as passed by address. Pre-calculate. Okay. Let's do one thing. Let's cut this, paste this here. Let's remove this. I don't want this. So I don't want this pre-calculate map. Don't keep it. For I result dot pushback secondary max. Even I don't want this iteration, but it's fine. I don't know, but it is taking a lot of time. 852 ms. Ah. A, condition if k is equals to 0. It is giving me DLE. But why? Its MNN is like 1000. I can, isn't it? Should not be n square. Why it is taking more than n square complexity? N square should be accepted. K is also 1000. For every node 1000, so it's 10 to the power 6. That is maximum this will take. This way is going to take. This is something I'm every time I'm initializing this visited array. Which is taking time. $693 MS. How can I like reduce the complexity more? Is there something else that I can do here? For the first tree, we run DFS from each node up to k edges. For the second tree, we run DFS from each node up to k minus 1 edges. We track the maximum of target in max2. We need to add max2 to the final result of each node in the first tree. This is what I did. M is equals to e1 dot size plus 1, e2 dot size plus 1, max is equals to 0. I created the two adjacency list. You find a resultant so he's not creating extra space. It's something we can track it that we are not going to the same edge again because it's a tree, so there'll be nothing So no visited I need. I don't need visited, I need parent. So the new node is adj list of current node of I if new node is not equals to parent, then call this, and parent will be current node. And here also I don't know need this visited parent. It reduced down to 138 millisecond. This will be accepted. Okay. Yeah, that was kind of a common sense. You could have applied it because it's a tree. Why to have extra memory space to in order to do the visiting part? The only thing that I need to handle is the parent. If parent is handled, then great. Okay. This was easy, R. This was easy. I would have solved it easily. Uh, Number of nodes that are target to I. If the first tree if you had to connect one node from the first tree to another node. If the number of edges on the path from okay node U is target to node V. If number of edges from path to from on the path from U to V is even. So if I connect 0 with 0, 1, 2, so like 1, 2, 1, 2, 3, 1, 2, 3, like Z from 0, right? So from 0 it is like 1, 2 here, 1, 2, no, 3, 4, 5, 2 length is completed, 6, 7, Height is 8. Cycle 2, 2, 2. So this is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. One, two. Hmm. So total in total 8. Okay, I'll do it. Hmm. Okay, let's have a 10 minutes of break, and after that I will try to uh, give the contest bi-weekly 145, and then we'll try to solve these hard level questions also. Okay, after this I'll be giving the contest, second contest. Okay, see you in 10 minutes. Okay, I'm back. Let's go. Let's give another contest. Let's solve. Let's do it. Okay, let's see. Sorry. Okay, so you are given an integer array nums and an integer k. Cool. An integer h is called valid if all the values in the array are strictly greater than h or identical. Okay. For example, if nums is this and a valid integer h is 9 because all nums I is greater than 9 are equal to 10. But 5 is not a valid integer. You are allowed to perform the following operation on nums. Select an integer h that is valid for the current values in nums for each index I where nums of I is greater than h. Set nums of I to h. I have to make every element in nums equal to k. Okay. If it is impossible to make all the elements equal to k, return -1. Okay, I need to select a kind of h as the constraint. It's only 100. The constraint only makes question easy, right? If the constraints are high, it's always going to be high stakes to solve it. Okay. I need to know, like, is it even not possible? What is the case when it's not possible to make it? When the value is lesser than k. When there is a value that is lesser than k, I can't. Strictly greater than k are identical. If all the values strictly greater than k, greater than h are even identical. So I need to always take the highest. Return the minimum number of operations required to make every element in nums equal to k. If it is impossible to make it, return -1. So there is some thing is like make it equal to the second largest element. The highest element will become equal to the second highest element. Now all the second highest element will become equal to the third highest element. And if any element is lesser than 2, will be out. So in one operation all 5 will become 4, so everything is 4 now except this. In second operation all 4 will become 2, so in 2 operation it's done. So see, it's 2 and the value is 1. We cannot. So that I need to like keep in mind, and I'll be doing what I will have to, like how many unique values are there, sort those values in ascending order or decreasing order, and the smallest value should be my answer. Even not the smallest value will be my answer. If the smallest value is equals to k, that will be my answer. And if it is not equals to k, if it is greater, the smallest value is still greater than k, I would say plus 1 to it. Okay, so keep all the values. Because after all, eventually I need to make it equal to, so unordered map will also work. It's not, that will not be any issue. For int now, if nums, the moment I got to know that nums of I is lesser than k, I'll be returning -1 at that moment only, else I'll insert it st dot. Insert nums of I, and I need to track the minimum. I need mini, that is mini is equals to minimum of mini comma nums of I, that is the smallest element, and answer will be equals to st dot size. Now if mini is equals to k, return answer, else return answer plus 1. No, is it so, right? So we have like 1, 2 and 3. Answer, it will be answer -1, else answer. 2 minus 1, 4. Minimum time to break locks. Bob is stuck in a in a dungeon and must break n locks. Strength 3, 4, 1, k equals 1. Bob is stuck in a dungeon and must break n locks, each requiring some amount of energy to break. The required energy of each lock is stored in an array called strength, where strength I indicates the energy need to break the ith lock. To break a lock, Bob uses a sword with the following characteristic. The initial energy of the sword is 0. The initial factor x by which the energy of the sword increases is 1. Every minute the energy of the sword increases by the current factor x. The initial factor x by which the energy of the sword increases is 1. What is this factor x? I didn't get it. Okay. Every minute the energy of the sword increases by the current factor of x. To break the ith lock, the energy of the sword must reach at least strength of I. After breaking a lock, the energy of the sword resets to 0 and the factor x increases by the given value k. Your task is to determine the minimum time in minutes required for Bob to break all n locks and escape the dungeon. Return the minimum time required for Bob to break all n locks. Okay, so needed to break the ith lock. So 3, 4, 1. 3 amount of energy is needed to break the first lock, and 4 amount of energy is needed to break the second, and 1 amount of energy is needed to break The initial factor x by which the energy of the sword is increases is 1 by current factor x. Okay, let's see what this factor is all about. Time, energy, action, x, updated x. Time 0, energy is 0, my x is 1, action I will do nothing, updated x is 1, time is 1, I have my energy is 1, x is 1, breaks third lock. Okay, I can break any lock. Okay, I need to break. Okay, so I'll break the smallest. Okay, I'll start with the smallest lock, what it seems to me. I'll be starting picking up the third lock. I'll break that lock. I'll update my x by 1. At second, time 2, energy is 2. I have energy 2, I do nothing. So x factor, x is the factor. So at time I broke the lock, my energy went down to 0. I updated my energy with the updated x, that is 2, but I can't do anything. So I need to wait 1 more minute. After 1 more minute, what will happen is my energy will be updated with 4. Now I can break the lock. Second lock. The amount of energy resets to 0 again, and then I have 3. Okay, I broke the second lock. And what if I would have broken the first lock? I had 4 energy, I broke the first lock, but that will create a problem because I wasted one amount of energy, right? I would have utilized it. Means whatever energy I have, find the perfect pair for that if it is possible or closest to that. Whom I can break. Okay. Let's see example 2, which will give me more clarity. Initially I have 0, x factor is 1, updated x will all obviously, because I haven't broken. So if I break, my x will update. At 1 second I have nothing. At 1 minute I got energy 1. At another minute I got energy 2 to break this lock. And the factor increases by the given value k. Okay. So the factor will increase by given value k. Okay, so earlier k was 1, that is why 1 was being updated. So initial factor is like 1, starting is 1. After breaking 1 lock, I can add that much factor, k factor, to x, and then I have energy of 3. That much energy I will be having. 3 second I can't do anything, but adding 3 more, will give me energy to break the bigger lock, which is nothing but lock 5. And then my factor will increase. Okay. mm, I was imagining, is it the one the lock that I'll be breaking should be like kind of a perfect match with the energy that I have, because picking up the smallest one, will that make any sense? That will like increase my time. If I broke the first lock, I broke the first lock here, and then my factor, I did nothing. My factor increased, my energy became 4, and if I try to break this lock, my energy will be added with 1 and I'll get 3. I need to wait for 1 more minute, so that'll be 5. So I can't do that. Means I shouldn't be doing that. Finding the perfect match, or even a kind of a lower bound. If it is a match, then fine. Otherwise, pick someone who is greater than this energy. No, 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 no. Always try with upper bound. Always have energy. So minus will give me the closest lock that I can break into. So kind of doing a binary search over there. N is only 8. Oh, okay. Doesn't it look like a pure recursive? Pure recursion, is it so? Is there something DP or some kind of thing that it's like I have options. I have this much of energy. Either I wait for this minute and then move forward, or I'll try to break any of the lock. I can break any of the lock. Try to break this lock, try to break this lock. If I'm breaking any of the lock, that will be removed from my... Okay, it's kind of looking to me like recursion, because if it is giving me strength is 8, I can try a brute force recursive approach over here. So okay, so what I will do, let's try the recursive one. Let's try. So whatever minimum will the time is something is of essence, right? I'm waiting, I'll add 1. K is my factor. How much energy initially I have is 0. Updated factor initially will be 1. Factor will be 1, right? So int solve is energy that I have, factor, or like x factor. I'll have this k. I want to know like strength. Do should I use array or should I go with um, the multiple possible? So unordered map of integer comma integer. Health current I is equals to 0, I is strength. Health of strength of I plus plus. So energy X factor K will be passed and pass the health. Let's see if I need anything else after this. Okay, so I have energy initially as 0. Like, is it possible to break any of the lock with this much energy? If not, if yes, try to break it, and even we can like save our energy and will increase the factor. There should be some base case where I will be stopping. Uh, there will always be a case where I'll be increasing my factor and increasing my factor, increase my energy. So there should be something, some case where I need to stop that via no more energy is required. It's always going to be like a greater than the maximum strength of a lock. Is it so? No, that's not good. If K is like very huge, but K it's saying it can only be, it can go up till 10. If K can go up till 10, factors can go, energy will like will go. There should be like something to stop my base case. Like what I am doing is this much with this energy. How many? Auto it is equals to health dot begin, while it is not equals to health dot now if it of first, that means health is kind of lesser than or equals to the energy that I have. That means I can break this. So if I'm breaking this, what will happen is my factor will increase. Okay, so energy will be equals to x plus k and factor will be equals to x plus k, even x plus k. This is what is happening. uh, I did nothing. My x did not change. It stayed as it is, right? I have energy to break this, right? So I will break it, and for next time my energy will become 3, and my updated x will also become 3. That means what I did, x plus k, and that is the same value my energy will be. So if it is possible, try to break it. Breaking means health of it of first minus minus. If health of it of first is equals to 0, health dot erase this. Now I will do what, how much energy we took. And it's like how much cost. Cost will be is equals to, I need to maximize, right? I need to maximum of sorry, I need to minimize the minute. I need to minimize the minutes. Minimize it. So time will be kind of int max or 1 9. Time is minimum of time comma 1 plus solve. Now the energy will become, hey, why x is capital, man, make it small. 1 minute, energy will become x plus k, and that same thing will be for factor also. My new factor will also be x plus k. K will go as it is, health will go as it is. See, and there will always be a case where So every minute the energy of sword increases by the current factor. If we are even we are if we are doing nothing, my so there will be a case where my time will be like minimum of time comma 1 plus solve energy and er energy will go as it is with a added of k factor. X will go as it is, k will go as it is, health also will go as it is. Now the moment I see health dot size has reduced to 0, I'll return 0. That means that I have like all the healths are completed, but I'm doing the second recursive call, which is always telling me there might be something. If because every time what is happening, energy is increasing. So k is always 10, so it will not increase more than 10 into 8, 80. So like every time if uh, 10 is being added, all the minutes we wait, 10 the minute we wait, 10 is added, 10 is added, 10 is added. We can kind of reduce because if I know that minimum strength I need this, then how minute do I have to wait? I'll have to wait some time. How many time? How many minutes do I have to wait for that? So for that we can, like, I have to wait like 5 minutes, then only I'll be able to reach to the strength, minimum strength. Okay, that is one way. What if let's take if energy is greater than, if it reaches 1e9, return 1e. My health dot size was not 0, and my energy is increasing every time. For smaller cases, just a second. Hello. Even okay, let's make it somewhere like 100. If I see, hey, line 13. What else can I think of? Why it is giving me heap buffer overflow? So my energy will be resetted to whatever factor we had plus k. And there's something else. It's not because of this. If IT plus plus I am doing health dot begin. If IT first, let me keep it in bracket. If IT first, that means health is lesser than or equals to the energy that we are giving him. Health of IT of first will be minus minus. And if it is like health dot erase IT first, time will be like minimum of time. 1 minute passed for breaking that lock and solve this and this. Still runtime error. And there is a case that if we do not so what will happen? Energy the energy of the sword increases by current factor, which is x, and x is what we are passing as 1. First time energy 0 1, second time I waited for 1 minute. My energy became one and one. So I broke, and then my energy became. Oh, okay. Just a second. Okay. Hmm. Why we are getting so 2 2? We did nothing. So time is 3, energy 4, and factor is 2 still. Factor increases by 1, 3, 3. So energy is 3. Why at 3 3? I picked this one. So my energy is 3 3. Line 14, it broke. But why it entered at the first place? It should have not entered, right? The size of the arrays is when energy became 1 1. So at 3 3, size of the array is this. Should not. This time line 15. Oh, okay. There's no IT ka first, bro. I removed it. Oh shit. So if I removed it, how my iterator will increment? Yeah, exactly. Okay. There is something. Will do what? Will reduce the frequency. Will not erase it. Let's not erase it. Will increase the frequency of this. Simple. Okay. We have a count. Count will increase. Now if count, so instead of count, gdh strength dot size, and count will reduce. And one more thing, if energy is less, and I did not do anything, so count will be passed as it is. Oh my god. This is the problem. It will take lots of recursive time to find answer, and that too is wrong. Why? 5 and 6. 341. 254. 4 and 5. Why it's 5 and 6? Energy plus K factor will not increase. Okay. I don't know if this is right or wrong. If I try it 100 or 1e6, it'll take huge amount of time. I know that is not possible if I take 100. But that is not going to be accepted, and even we are getting wrong answer. Zero, really? We have 3, we have 8. 4 0 0. Didn't even go in. 1 plus energy. Oh, if count is 1, it returned 0. It will not be submitted, bro. I know that. Larry is OG. Yup, exactly. Big fan of him. LB time limit exceeded. Yeah, I know that. No, agreed. I don't know. No, this is the problem. Oh, okay. Sorry. The output is this. What I expect is something like this. 461515. Why? Oh, okay. Every time one will be added, until unless we reach 461515. So this will energy will go like 461515, and that I do not want. I need to reduce it. This adding one every time, I don't want this. I need to reach to how much time it will take to reach to the smallest one, that I need to find. So instead of like doing unordered map, we can track the map. Mhm. And even Larry's solutions are really amazing. Like how can we do it? This is something blocking me for going. Is it possible to de-memorize this? We have energy. Energy can go till 10 to the power 6. X is the factor. It can also extend. K can go till 10. Not any issue with K. Health is changing. Count is changing. Count will also go. Count will go till 8. K will go till 10. These are the two things that will go beyond. Pure recursion, will it, is it any kind of help? Is K changing? No. K is fine. X is changing. Factor is changing. Energy is also changing. X is also changing. Energy can go up till 10 to the power 6. X factor can also extend up till 10 to the power 6. These are the two. Then they both can extend up to 10 to the power 6. Is it somewhere memoization or something? But how can we apply? We are having two things. They both are variable. They both are changing. Even I can make this, but will that help me? Mm. Let's try that also. If not, then we'll see the discussion forum. But let me see if I have a map. So map will keep the smallest value at the top, but I have it. I have those values also, which I do not want. Okay. Health of IT. Oh, okay. Let me see. This recursion is backtrack with bit mask. Simple recursion with bit masking. Built-in permutation function. Simple. Hey, come on. Why did current time solve strength temp k mini is equals to minimum of mini comma current time? What is this next permutation? Minimum time required to solve all the locks in a sequence where each lock requires a certain amount of energy. And the available energy initially the level input we are providing with a strength array. Each element can represent the energy of the required lock. The order of in which the logs are resolved affects the total time, and hence we need to test all possible permutations of the lock. For each log we calculate the time required using the formula time is equals to current energy level and energy required. After each log the current energy level increases by k. Brute force with permutation. Generate all possible permutations of the log, order and calculate total time for each permutation. The goal is to find. Wow, okay. So if I found out all the permutations and to generate all possible permutation of the logs and computes the time for each permutation was simple and correct. It has a factorial time complexity which can be inefficient for larger inputs. Exactly, I know that. What is this one liner? Use bitmask to maintain which locks have been broken. Because this is only 8 length, we can use the bit masking approach. Intent is equals to size. So I sort the strength as fine. Sorting strength I passed 0 is my current energy, 1 is my factor, k is my times increment, and 0 is my temp. I don't know what this temp is, but let's see. Mask is equals to 1 left shifted n times minus 1 s dot size. If all are masked, okay, this is the case. If all are done, then answer is this, and return answer will find the minimum of answer, else return. If that has been already completed, continue, else like where is that possibility? Oh, okay, so he's not even calling the second function. He's saying that to reach there, how much amount, the one that I was thinking, to reach there, how much amount of energy do I require more, that needs to be added, and then that is now being masked, and x add this add amount of time will be added, in this temporary. S is what? My strength. Mask, I created this mask. X will be added with K because I'm unlocking that lock. So factor will increase by K, and temporary dot add. Now add is calculated as s of I plus x minus 1. The current strength, to reach there, this much amount of energy is required, amount of time required to reach there. How much time do I require to reach there? Okay. mm, Masking, like this is what I need to understand. S of I, current strength, plus factor minus 1 divided by factor. Why we are doing this? And that much time will be added. So do I even know the current time? Okay. As of okay. This is something like they are doing like extra work for like doing the bit masking, like over solving the question using bit masking. They wanted to show that if the constraints are less, we can use bit masking, which will help me in a lot easier way. The only thing that I can calculate the time required to complete task I. Yeah, I know that this they are calculating the time, but how we are even calculating the current strength is like 20 and my factor is 1. So 1 minus 1, that is 0. 0 divided by 1. How much time it will take? 20. If my factor is 2, how much time it will take? Uh, how much time it will take? That is 20. 2 minus 1, that is 1. 21 divided by 2, that is 10. How he came up with this? Can you just tell me? Okay, this is working. It's fine. Okay, take every permutation of strength vector. For each strength, the time taken would be strength of I divided by the factor plus strength of I modulo increase equals to 0. Then 0. If it is more, then add 1 to it, which can be written as this. That's why. Okay, now I got it. Strength divided by the factor, that will give me the times, and if there is something, if there is something remains, I'll add 1 to it. Yes, this is the actual calculation of timing, which turns out to be like this. By adding kind of plus 1 if there is something. Maybe let's try with the bit masking only. Why can't we? Showing off the skills is always good. Hmm. I have this strength. Current energy is 0. Factor is like 1. K is this much and 0. And I need a mask. Mask initially, mask will like current energy is this much. So I don't need energy now because I'm calculating how much energy do I require, how much time do I require to reach there. So it's simple as that. So I'll even sort and gth strength dot gth strength dot end. It's like int result 1e9. I don't need to give anything because let's see if it requires anything or not. Vector int ampersand. Let it be nums. Mask int kind of factor and int. Okay, now if mask is equals to I need nums dot size also. Mask is equals to 1 left shifted n times -1. If this is the case, then result is equals to and I will be passing 0 as my answer. No, right, I need to minimize the answer. That is fine. Now I need to check if the current element has already been used or not. So if I'm using the current if current element is already used, that has to be masked, right? So if okay, if mask and with 1 left shifted I times is equals to 1 is giving me 1, then this has already been masked. And if that is not masked, I'll mask it and I'll call again. So I need time is something thing, I have the current strength divided by the factor that I have. Now plus will be if nums of I modulo factor is equals to 0. If that is the case, then I'll pass 0, else I'll pass 1. That means if there is some value, then I need to add one more, because one more time will take to complete that. Right, so I'll do what I'll call solve. Nums will go as it is. Mask will I am masking this current value, so it will be odd with one left shifted I times. Factor will be added with k. Right, k will go as it is. Answer will be added with time. Even I don't want to sort it. Why I am sorting it? I like. Achha. Precedings issue. Let us see. Operator question mark and colon has lower precedence than plus. Edit first. It's a warning. There is error. Strength 0 1. Use of declared identifier k. Oh, it's a capital K. Deadly signal. Return. Who will do return? Stack Overflow. This is only in the case for if all are 1. So it's kind of 2 to the power. Three minus 1, so 1 to the power n minus 1. Yes, it's correct. What runtime error are we getting? Come on, yaar. I am checking. Is there anything that I'm doing wrong? mask uh, and it with one left shifted I times. If that is giving me 1, I'll continue because this has already been masked. Else not, I'll mask. It's correct, right? Factor will be added with k. Why it's failing? Now this next permutation, it's fine with bit masking approach only. I need to know 1 left shifted n times -1 will give me the maximum value, and if it is equals to my mask, I'll make my answer, I'll return. Sum is equals to x. Mask and it with 1 left shifted I times. If it is 1, I'll continue. This is what I wrote also. Mask and with 1 left shifted I time is equals to 1. I'll simply continue. Else I have this time which I calculated by factor. Doing or factor plus k will go as it is, temp will be added with the add that we have. This is the only thing that I am also doing. What is the use of this sum over here? Are we even using this sum? No, there's no use of this sum. Why I will add that sum? It's a waste. Even if I do not compare, that will not affect my answer, man. It's a deadly signals. What? Oh, it should be greater than 0. And it should not be 1, it should be greater than 0, because the value it will give me will be greater than 0. Now the answer is 0 0, which I do not want. Is anything wrong that I'm doing? The only thing is calculating this time, and this is correct. This is correct only. Modulo factor is 0, then add 0 or 1, maybe something like this. That precedence issue. This will be calculated first and will not be added. And if we do not sort it, then also it is fine. Why to sort it? So I had to have this using bit masking. Even if we do not use bit masking, we could have used normal, but I was doing was kind of two recursive call, and stopping the second recursive call was like a hell of a task, as it'll take a lot of time. It'll go time limit exceeded for sure. Nice. Nice. It took a lot of time. It took a lot of time to understand this bit masking. It always slips from my mind. It always slips from my mind. Whenever I have this constraint so less, why can't I use bit masking? That's something always going to help me whenever if I'm using a bit masking approach to this. Should have used it. Okay, no problem. Okay, fine. Then I think I'll stop here for today. I'll be trying these rest of the questions. Not this one, and this one. After some time, like 1 or 2 hour after that. So I'll be solving those questions also after taking some break. So that is for today. I hope you learned something. I learned too. I used to forget about the bit masking. I know how bit masking works. I have solved plenty of questions on bit masking, but I always forget when to apply bit masking. The thing that I got to today was like, when to apply bit masking is when we have constraints very less. That is one point. And second thing is, we need to find all permutations that are possible. So if we need to find all the possible permutations, we have to have that, like, bit masking is the first thing that should come in our mind. Then only we'll be able to solve it. So if constraints are less and permutations are we need to find, then go for bit masking. It's always going to help you. Nice. Okay, then I hope you guys also enjoyed. I'm sorry. I hope you also enjoyed. Thank you for watching. See you next week, Saturday, 9:30. Till then, do lead coding and improve your brain. I'll be also improving mine in these meantime. Okay. See ya. Bye bye. Thank you for watching.